Given the following function, they give you an absolute value function and they graph it for you, where the vertex is 2 and -3, 2 and -3, and they ask you to graph 2 f of x. That means that you're going to multiply by 2 the function. Now, remember that when the f of x stands for the y, so 2y. That means that you're going to multiply your y values by 2. Your x values will stay the same, but the y values will be multiplied by 2. So I'm going to grab my vertex first. My vertex is 2 and -3. 2 and -3. I'm going to multiply my y value. So instead of being -3, multiplied by 2 will give me -6. So 2, 4, 5, 6. And you can do that with each point. So the next point, I'm going to grab it this point here. 1 and -2. 1 and -2. I'm only multiplying my y value, which is -2, by 2. So it becomes -4. I'm going to grab my other point, which is 3 and 2. 3 and 2. And I'm only going to multiply my y value. My -2 is my y value, multiplied by 2 gives me -4. And you can do that with every single point. But from here we can just go and shape my absolute value, and that'll be my new function. Now remember that whenever you multiply by 2, your a value also gets multiplied by 2. So if you want to just get your vertex, and then the next point, instead of being 1 away, will be 1 times 2 is 2 away. That works as well. Now to find your equation, you gotta multiply by 2. So let me write down my new equation. Absolute value of x minus 2 minus 3, and I'm going to multiply by 2. The 2 be multiplied by your leading coefficient, which is 1, by your a value, and also by your -3. Do not multiply the -2, because that -2 is already being taken care of when you multiply your a value. So your new function will be 2 absolute value of x minus 2 minus 6, and let's call this g of x. And if you check your vertex is 2 and -6, and it should match. 2, -6, it does. And your a value is 2, and it also matches. So that's your correct answer.